Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett. On this channel, we cover all things Gen Chem related. On this video, I'll be introducing chemical bonding and we'll learn how we're going to set up doing Lewis structures. Let's get started. In this video, we'll be introducing the foundation to chemical bonding and what we know as the Lewis theory. So there are a number of theories out there that are used to help us to understand why and how different atoms are able to be attracted to each other. There's also theories out there that help us to explain why certain combinations are allowable and stable and others are not. Now, the main theory that we use to help us understand what we know as the foundation is based off of work that was done by G.N. Lewis, and it is known as the Lewis theory. Now, the Lewis theory really emphasizes the focus on valence electrons and explaining how they are involved in the bonding process. By using the Lewis theory, we can actually draw models and make a lot of predictions about the structure of the molecule and also other properties such as stability, shape, size, and polarity. So the first question that should be coming to your mind is, well, why do certain atoms bond to each other? Well, the reason they bond is because they are looking to ultimately lower the potential energy of that system. And so as they're forming these chemical bonds, you're actually able to lower the amount of potential energy that exists between charged particles that compose the atoms. And the potential energy that is there is associated with the directly proportional, the potential energy that is present between charged particles is directly proportional to the product of the charges and is inversely proportional to the distance between the charges. So for the bonds that we're going to be looking at, a chemical bond forms when this potential energy of a bonded atom is less than the potential energy when they're separated. Now, to calculate this, we need to consider things such as the nucleus to nucleus repulsions that exist, the repulsions from the electrons that are there, and any attractions that may be present from the nucleus to the electrons. Now, mark this slide because this is really helping us to understand the three main bonding types that we're going to encounter. And really, we'll only focus on two throughout this semester. So the first type of bonding that we're going to deal with is ionic bonding. Now, we heard these terms introduced back in chapter 3, and we're just going to revisit them. So remember, in ionic bonding, we have that transfer of electrons that's occurring. Your metal typically is losing electrons, your nonmetal is gaining electrons, and as a result, you have these charged species that can be attracted to each other. Our second type of bonding is covalent bonding. Now in covalent, as that word implies, co meaning shared, valent means the valence electrons, they're going to be shared amongst the atoms that are present. And we'll primarily see this when we have nonmetals and nonmetals coming together or nonmetals and semimetals. And then the third type of bonding that we'll talk about very, very briefly in this video is metallic bonding. Now, metallic bonding happens when you only have metals present. And instead of transferring electrons or sharing electrons, their electrons actually pull on this outside of these cation shells and are able to cause attraction in that manner. And so pictorially, you can see all three of those different types of bonds shown here. Again, your ionic bond, if you remember, you've seen this picture before back in chapter 3, that ionic bonds don't exist as individual molecules. Instead, you have these repeating positive and negative species or this crystal lattice structure that exists. Whereas covalent bonding, we do have those discrete individual molecules. And then again, like I said, with the metallic bonding, what you end up with is a sea of electrons that are hovering around this cation core. So let's dive a little bit deeper into our different bonds. So again, with ionic bonding, remember the metal is going to be losing the electron to form a cation. And this should make sense to you if you've seen those ionization energy trend videos. Remember, metals have very low ionization energies, and it's very easy to remove an electron from those atoms. And we know that nonmetals, they tend to gain electrons and become anions. And this is right in line with the fact that nonmetals have high electron affinities, and they would like to release a lot of energy when they gain electrons. Now, the generation of these positive and negative ions that are able to be attracted to one another is where we get our ionic bonds formed. Now, covalent bonds, remember, they're a little different. In this case, because we're dealing with two nonmetals, we're dealing with two or more species that have relatively high ionization energies, meaning it's going to cost a lot of energy to remove an electron. So rather than try to remove electrons to make them more stable, they actually come together and bond with one another to share their electrons to create a stable environment around all the atoms involved. Now, these shared electrons hold the atoms together by attracting the nuclei of both atoms. And then last but not least are metallic bonds. Well, remember with metallic bonds involve only metals, and metals have those low ionization energies associated with them. So it's very easy for them to kick out those electrons. And so in this case, as you are kicking out those electrons, you're creating this sea of cations that are localized and then can be surrounded by those electrons surrounding it. And then the bonding results from the attraction of the metal cations for the delocalized electrons. And once again, you can see a picture here of your metallic bonding. If this video helps you understand the different types of chemical bonding that will occur, please make sure you guys come back, like, comment, and subscribe, and let me know what other content you want to see. Have a great day. Talk to you later. Bye-bye.